Dam is not only constructed or designed for water supply or for irrigation, but it can incorporate hydropower and to supply electricity as well. So this project requires a very careful technical and financial studies, because every project is site specific for it to be feasible, for you to achieve your aim. It requires a very careful technical and financial studies to see whether you'll be able to do it. So, and the amount of energy generated, since it's incorporated with hydropower, the amount of energy depends on the volume of water, or the quantity or the amount of water available that will flow throughout the year. And that is why you need a very careful studies, feasibility studies to do it. Because if you don't have enough water to flow throughout the year, the energy generation will be low. Or sometimes it may not generate at all because the water cannot move your turbines and other things installed. So before that is done, you have to take some important considerations. The first one is the dam itself, the storage capacity or dam storage capacity. You know, the dam is an impoundment across the river or rivers or streams. Any obstacle you want to divert, that is the dam, to divert the water. So, first of all, you must consider the storage capacity, which we call the reservoir. What is the size of the reservoir? How will the reservoir match with what you have in mind? Will it contain adequate water to match with what you have in mind? So in order to know this, the dam storage, you use this formula which was given by FAO in 2010. Q is equal to L times T times H prime over 6. So this is the formula you can use to calculate your dam storage or a dam reservoir. And here, Q is the quantity of water or the storage capacity in meters cubed, cubic meters. Then L is the length of the dam. The length of the dam in meters. While T is the throwback of the dam. The throwback of the dam, that's the reservoir, and also is in meters. While your H is the maximum height of the dam when the reservoir is flowing through. It's also in meters. So another thing we must take care of or note in dam storage capacity, the capacity should be at full storage level. When it is at the full storage or full supply level, without overtopping. This is very important. So what is the full storage level of the reservoir without overtopping? Because if overtopping happens, it has destroyed your dam, to destroy many things. So that is important. To calculate this, you use this formula which was given by FAO in 2010. Then the second thing we are going to consider is the catchment area. You note what is the catchment area of the dam. And this catchment area will mean all the the area that is supplying water to the river or the stream, or rivers or streams that are impounded. Look at this here. This is the outlet. All the areas supplying or contributing water, contributing flow to this river that you have impounded. So the inflow into the catchment area matters. You must know what that is coming, whether it will sustain your project. And in order to note or to calculate the yield from that area, you use y is equal to q multiply by a multiply by 1000. So after noting your catchment area, what do you need from this catchment area is the yield, the volume that will be able to sustain your scheme. And y, from here, y is the catchment yield per unit time, the catchment yield per unit time in a year, and is measured in cubic meters. Then Q is the direct uniform runoff, the uniform runoff Q, which is measured in millimeters. Then finally you have the area of the catchment, which you have determined, and the unit is in square kilometer. The square kilometer. Now, when you note this from your studies, this will guide you to know whether your project will be viable or not, to know whether your project will be sustained or not, to know whether your project will be efficient or not, whether the aim, what you have in mind, will be achieved or not. Then, there are another thing you will consider. Another important point you will consider is the catchment area peak flow. The catchment area peak flow. Or you can say peak flood. Still either the peak flow or the peak flood. On the flood is the runoff, which will power your engine or machine. So what will be at the peak? When the flood is gathering, at the rains, when will be the peak? So what is the peak like? If the peak is not encouraging, you can imagine what when you are out of the peak, how it will look like. So also, according to FAO 2010, you can still calculate the peak like this. That's maximum flow, Q max. You calculate it as C multiplied by A to the power 0.8. Multiply it by 1 plus 0.8 log T, and you multiply it by 1 plus 2.67 multiplied by A to the power 0. minus 0.2. So This is how you get your maximum peak flow from the catchment. Then C is the runoff coefficient. That's this C. While A is the area of the catchment, as we said earlier. T is the reoccurrence interval. Reoccurrence interval. While Q is the maximum flow. We have said it. So you see that all these are very important. So this recurrent T, A, that's the area, runoff coefficient C, that should be noted so that you know the effect, the peak flow or the peak flow we have on your project, whether it will be viable or not. Then the fourth thing we are going to consider, or the fourth important thing that's supposed to be considered, is sedimentation of the reservoir. Sedimentation of the reservoir. You have to consider the sedimentation of the reservoir because it is very, very important. Sedimentation reduces the capacity or the storage capacity. When the sand has covered the reservoir, you know, the volume of water, the quantity of water is reduced. So how do you take care of it? So you must note when there is sedimentation, you must do the cleaning. You remove the sediments and so on and so forth, which is very, very important. So because when there are flows coming, they are carrying sediments, debris, sand, all whatnots into the reservoir itself. And this reservoir, that it will settle silt and whatever. That reduces the capacity, the storage capacity of the reservoir. So it's very, very important. So what are we saying? In planning and design of a dam that will incorporate hydropower, all these things are important. The dam storage, catchment area peak flow, then sedimentation of the reservoir. There are other things you will consider, like you must consider safety. You must consider safety. Safety is also very, very important. You must also consider your drainage, because if the full storage level is exceeded, there will be overtopping, which is not good for your project. So in other words, you must make provision for drainage so as to reduce releasing some of the water when you foresee danger through the spillways and other things. So of course you will also consider your finance. What does it require? What does it require to set up that project? So all these are very, very important to consider, and so on and so forth. So thank you for listening.